Hello, everyone. Let's consider such a tuple characteristic as immutable. Let me remind you that the Python tuple is a collection of objects separated by commas inside parentheses, but the syntax allows without parentheses. Let's try. Change a single element, add a new element, delete a single element, and completely remove tuple. I will also give example of object that are immutable. Let's create a tuple with the 3 elements. When checking, it's important to understand what object we are working with, so we will display the ID of the created object and its elements. Let's create a new tuple, myTupleCopy, which will refer to myTupleBase. We can see that the elements from the myTupleBase are not just copied into the new variable myTupleCopy, rather they point to the same memory area. They have the same ID. Let's try in myTupleBase change a single element, for example the first one. We make sure that individual elements cannot change in tuple. Next, let's try to modify the value nested within a nested element of myTupleBase. In our case, let's replace 10 with 15 in the third element. There is no error, which means that in mutable elements such as list, dict, set, it's possible to change values nested within them. At the same time, the container object itself doesn't change. We see that the ID of the third element in myTupleBase remains the same. We also observe that the variable myTupleBase and myTupleCopy remain dependent and point to the same memory area. Let's try to add a new element to the tuple myTupleBase using a list. That is, first we convert our tuple into list. Next, add a new element to it, the string hello, and finally convert it back from a list to a tuple. At first glance, it seems that everything is okay with myTupleBase. The new element hello has appeared. However, if we look at the ID for myTupleBase, it has changed and now points to a different memory location. Additionally, the connection with the variable myTupleCopy has been broken. Now these are two independent variables. You need to be very careful with such workarounds, because if there are dependencies between variables, it's possible to break functionality. Let's try to add a value to a mutable element in the tuple myTupleBase. To keep the experiment clean, let's restore the dependency between our variables, myTupleBase and myTupleCopy. Let's add, for example, 25 to the third element. There is no error. Everything went well. In mutable elements such as list, dict, set, it's possible to add new values. At the same time, the container object itself doesn't change. We observe that the ID of the third element in myTupleBase remains the same. We also notice that the variable myTupleBase and myTupleCopy remain dependent and point to the same memory location. If you look at the definition of the tuple class, it really doesn't have any public method that would allow us to modify internal elements. However, it's a private method add. Let's check if we can get a backdoor through it, which will make it possible to extend a tuple after its creation. This method can be called in two ways. First way, let's add two new elements to myTupleBase, hello and world. Wow, elements have been added. Did we hack Python? No. In really, no magic happened. If we look at the ID for tuple base, it has changed and now points to a different memory location. Additionally, the connection with the variable myTupleCopy has been broken. Now these are two independent variables. Second way. As we can see, the result is the same. We added elements, but in fact, we just created a new instance of the object. There is also the option of adding two tuples. Let's check it. Essentially, the hidden method add is used when adding two tuples. Let's try to delete a specific element, for example the first one, in the tuple myTuple base using the del keyword. We confirm that individual elements cannot be deleted in a tuple. Let's try in myTuple base remove a separate element, for example the first one via list. It may seem that the list approach worked and it was possible to remove the first element in tuple myTuple base, but in fact another instance of the tuple object was created, which looked at a different memory area. As a result, the variables myTuple base and myTupleCopy become independent of each other. This conversion is suitable if there are no dependencies on the tuple variable. Let's try to delete a value nested within a mutable element in the tuple myTuple base. For example, let's remove 30 from the third element. There is no error. That is, in mutable elements such as list, you can delete nested values. We also see that the variable myTuple base and myTupleCopy remain dependent and look at the same memory area. Let's try to completely clear a mutable element in the tuple myTuple base. In our cases, this is the third element with the type list. There are no errors, meaning that mutable elements such as list can be completely cleared. The variable myTuple base and myTupleCopy remain dependent and point to the same memory location. What if we try to completely delete the tuple myTuple base and see what happens to the variable myTupleCopy? There are no errors, meaning that it's possible to completely delete the tuple variable. It's expected that after deletion, we can no longer access myTuple base. The variable myTupleCopy continues to point to the same memory location and all its elements are preserved. Examples of mutable and immutable objects. Results of all test cases. That's all. Thanks for your attention. See you again. Bye everyone.